Tom, what is the theory of Albert Einstein's general relativity?
The theory of general relativity allows us to explain the birth of the universe, the orbit of the planets, and black holes. But what is this theory exactly, and why was it so revolutionary? Sit down, Jerry, and listen carefully. Until the beginning of the 20th century, physics was dominated by the laws of Isaac Newton. The English physicist and mathematician claimed that gravity was a force caused by the mass of objects, attracting them to each other. The object with more mass exerts a more intense attraction. That's why we stay on the ground of the Earth, attracted to its center. And why do the planets move around the sun? But imagine that the sun suddenly disappears. According to Newton's theory, the planets would instantly process their orbits because there would be no more gravity to attract them. For Newton, gravity was a force of action independent of the distance between the bodies. However, Einstein encountered a problem. According to his calculations, light was the fastest thing in the universe. No body with mass could exceed the speed of light, not even the force of gravity. The sunlight takes about 8 minutes to reach the Earth. So, if the sun disappeared, how could the Earth be released from its orbit before we stop seeing the sunshine? These questions pushed Einstein to seek an explanation different from gravity. Between 1905 and 1915, he developed the theory of general relativity. He imagined the 3 dimensions of space and the dimension of time forming a fabric called space-time, deformed by the presence of massive bodies. Using this idea, it is as if the sun was a heavy ball placed in the middle of a trampoline, making the fabric bend. This curvature creates what we feel as gravity. Thus, the Earth and the other planets remain in orbit, not because the sun attracts them directly, but because they follow the curvature of space-time created by the sun. Gravity can no longer be considered as the force of attraction between 2 bodies, as Newton thought, but as the effect of the curvature of space-time on those bodies. If the sun disappeared, according to Einstein, destined space-time would create a gravitational wave moving at the speed of light. We would stop seeing the sun at the same time as the Earth would change its orbit. Einstein demonstrated that our vision of the universe was wrong. His theory made him a world-renowned figure and has enabled science and our imagination to rise ever higher. Even today, general relativity continues to surprise scientists and to fascinate us.